All right, today's lesson is about composites of functions. It's such a weird thing, the composite of functions. So you got all these functions. You could have many of them. Here's f, here's g, here's h, whatever. And they got this wacky little symbol right here, which gets mistaken for a multiplication dot all the time. But it's like an open little symbol. And it is like following is how you say that out loud. Okay, that's like following. So imagine that if Johnny right here was following Bobby down the hallway, right? If Johnny is following Bobby, who's really in front of who? If Johnny is following Bobby, who's in front? Bobby's in front because Johnny is following him, right? This says F following G of -2, which we just got to get the order down. If F is following G, right? F is following G, who's really coming first? If F follows G, who comes first? G. So our job is, they just have numbers right here for these first few examples, is we got to find G of -2. I'd like us to show work like this. Let's find G of -2. And that means we put -2 in for x into the G function. And quite honestly, I really don't need a lot of work shown on that. You can just punch that in your calculator if you'd like to, right? Let's put -2 in for x. Let's do it in our brain. What's -2 times -2? 4 plus one more. And is everybody cool that G evaluated at -2 turns out to be 5 in that case, right? So then, once we got that done, now we got to take the result of that homeboy and put him into the f function. So it's not like you're finding f of -2 again. You're now going to find f of 5. So whatever you get from the first one, like you put into the second one. So f of 5, that's a simple one. 5 times 5 is 25. And the final result is what you get when you're all done. So composites is like you're putting one function inside of another function, inside of another function, inside of another function. I have a story problem after this that'll make perfect sense, but I just wanted us to get the general idea down first. So you find G of -2 because G comes first. Got it. It's 5. Then you find f of 5, which is 25 in that case. Let's do that again. Who comes first? They don't use the cool little circle symbol, but they use parentheses. Don't we have to work from inside parentheses out? So here's a 3. Nothing you can do with it. What function do you think you should put it in first since we go inside out? Should we put it in H or should we put it in G? Put it in H. Let's find H of 3. I need you to write that work down for me. Again, you can do the work in your calculator, but let's find H of 3. This, I definitely need a calculator. Let's put 3 into parentheses. So let's punch that in together. 3, got to get squared. Got to put it in parentheses, though, because if that was a negative being squared and you don't put it in parentheses, bad news bears right there. So 6 times 3 plus 8. How do you feel about getting a 35 back in that case? 35 is nice. Then we got to take what we get for this guy and put that into the G function. So we'll find G of 35, if I could write correctly. So please put 35 into the G function for me. See what you get. If you need to punch it in, great. If you've got some mental ability, that's fine too. Too many 5s. -2 times 35 plus 1 is it -69. Is that what we get? -69. Sweet. Next one. Tell your neighbor if F is following H. The way you really, most mathematicians say this out is F of H, you know. So F of H of -3, but it's really supposed to be following. But if F is following H, who comes first? H. Little shortcut, so is the last dude. It's like reverse order. You know, the last one is what you do first. So let's find H of -3. And I'm going to pause the video and let you guys punch that in, H of -3. And I got it punched in, and I punched it in 2 different ways. You'd think they'd be the same thing, but they're not even close to the same thing. One of these is right, one of these is wrong. Which one of these do you feel is the correct one, the top one or the bottom one? Bottom one, because you put the negative number in parentheses, and a negative number getting squared turns out to be positive. If you don't tell your calculator that, this is going to make this a -9 when it's supposed to be a +9 in that case. So use parentheses. So we got -1 back, and now we got to put -1 into the f function. So f of -1, I want you to write it down so I see what you're doing, but you can definitely do that mentally, and isn't that totally -5 in that case? Cool. So last one, I'll let you pause the video. Find H of G of 4. Realize you're working inside out. All right, so I found G of 4 to be -7 and put that into the old H, into parentheses, and got a 15. So pretty weird, you know, but let's do a story here real quick and see how these things really make sense. With the story, I think you'll kind of get what it's all about. So Discount Dreyer's Factory Outlet is having a major sale, guys. It's almost the end of summer, so Discount Dreyer has marked all his Speedos down at 60%. Hope you know what a Speedo is, but he's got to get rid of them. So check this out, though. They're going to ask us later to write these discount formulas and stuff like that. If it's 60% off, right, if it's 60% on sale, then what percent will we pay? You know, if they're taking off 60%, we will pay 40%. Can you kind of see where that came from? Like, the discount formula is 0.4 instead of 0.40 times whatever the original price was. So if you save 60%, you're going to pay 40%. So that's the formula, the discount formula for the cost of the Speedo. Monty really has his eye on a nice pink Speedo, so he's excited for the sale. The original cost of the Speedo was $25. Amante will also have to pay 8.75% sales tax on his purchase. So here's the tax formula, right? You know, you change that 0.875 to a decimal, but you got to pay more than 100%, right? So it's this number right here. What is the correct composite for the price Amante will pay? So it doesn't get any more real life than this. You get a discount and you got to pay tax, you know? What happens first? Like if you was in the store yourself, do they make you pay tax first on the original price, then give you the discount, or do they make you do the discount first, then you pay tax on that? What do you think? Who comes first, the tax or the discount? Discount comes first. So look through these four choices, and let's see which one of those has the discount coming first. What does this guy have coming first? What comes first? Tax. They're going to tax it, then do the discount. Do we want that? Nope. How about this guy? What comes first? Discount, then you pay tax. Doesn't that work that way? That's what we want. Look at the other ones, though. This is pay tax on it, and then pay tax on it again. Would you believe that that would be really dumb? And then this would be the best. Here's a discount, and then get another discount in that case. And so would you believe that choice B is the correct multiple choice in that one? That's where the discount comes first, and then the tax. So let's find the price that Amante paid for the Speedo. First, what do we got to do, the discount or the tax? So let's do the discount of 25. Where did I get the 25 from? That's how much the Speedo was originally. So 0.4 times 25, because you're paying 40% of it. And would you believe that if it said originally $25, it is on sale for $10, right? So it's nice, you know, $10. But now we got to find the tax on that $10. When you take it up to the register, they will make you do that, so you can punch that into the tax formula in that case. You have to pay 8.75% sales tax. 1.0875, missed an 8, times 10. And then we'll round. This is money. So when you go up to the cash register, how many decimal places do they round the money to? 2 decimal places. And we'll round her up. So $10.87 or 88 cents. Look at that. Beautiful. All right. So that's the whole idea behind composites, is one thing has to be done before the next in that case. With a story, they make a lot more sense, you know. With the plain old math, it's just, Now, talk about plain old math, let's get some more plain old math, is now, if we look back to the first few problems, they had a number in this position. Now they don't. Now they just have an x, right? So we got to find f of g of x, and we got to find g of f of x. And we have to see if there's any restrictions in the domain. Well, here's the thing. The first function's domain rules the roost in this case. Whoever is the first function, that's about the invite list that were invited over to the party, right? So let's do that for both guys. Who would be invited to F? Is there anybody that's going to cause trouble in F? Is there anybody downstairs? Is there anybody under an even radical? Any troublemakers? All reals, invited. How about G? All reals? Cool. Now, tell your neighbor who's coming first. F of g of x. Who's going first? G goes first. So here's what I do when I'm a newbie at this. I still do it, and I'm not a newbie. G, like we got to find g of x. Okay, it's this. This is g of x. Like there's no work to do to find it. They told us what g of x is. And then we take that result. So I put a little box right here, and it has to go substituted in for x into the f function. So like this guy has to get substituted in parentheses in this dude. So I'm going to do that. I'm going to write f of g of x. I would also like to show you that it's not the word fog. Like this is the word fog if my pen would wake up. You notice how like all three of those things are the same size. The F, the G, and the little composite symbol are the same size. It's not the letter O. It's a little bitty symbol. You know, it's just a little open dot. F of G of X. So looks like so. And let's substitute her in. So putting it into parentheses. X minus 6. Quantity squared plus 2. Let's see if we can square that binomial correctly. Square the first guy. Twice the product. Square the last guy. Square the first guy. The product of those is negative 6x, so twice that is negative 12x. Square the last guy. And you still got that plus 2 that was still hanging out. So I can go up and put that final combined answer in my dude here, because I could easily combine 36 and 2 together to be 38. And they want to know what the domain of this guy is, not who's restricted or anything like that. They want to know who the domain is. So first, let's talk, is there any bad guys? Remember, everybody was invited over in the first place, right? Sneak downstairs or go underneath a radical. So is there any bad guys? So what's our domain? We'll put it in interval notation. What's our domain? There's no bad guys. So who you want? Negative infinity to positive infinity. Right? Cool. That was f of g of x. Now reverse, reverse, reverse. Let's find g of f of x. And I personally go back up to my original guys. The invite list doesn't change. Oops, I erased the problem. But now I'm going to do the reverse. F, this guy, meow, 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 has to go in for x into g, because we don't have any numbers. Before, we could like compute f of 5 or f of 11 or anything like that. Here they want us to compute f of x. Okay, it's x squared plus 2. That needs to go in for x in this guy, so x squared plus 2. Notice it was just an x. It wasn't being squared or cubed or have anything in front of it, so I don't need any parentheses. And there's a minus 6 there. Right, so the purple thing is f of x. It went in for x. And then you have to take away the 6. So that is x squared minus 4. Don't factor it. Don't do any of that. There's nothing that needs to cancel. You know, we don't have a fraction where we're trying to say, well, that's a difference of squares, sir. You know, there's no need to clean that up any further. Just realize who's his domain. Everybody was invited. Did anybody get kicked out of the party? So who's his domain? Please say all reals. Who's his domain? Thank you. Everybody's cool when you do that composite. Let's try again. Let's figure out who's invited to the parties. Check out F, check out G. Talk it out with your name. So everybody's invited to F's house. There's nobody downstairs or underneath a radical, and everybody's invited to G's house. That's nice. Who comes first? If F following G of X or F of G of X, who goes first? G. Let's take G and put him in for X everywhere. That's a tricky one that people ask good questions on. It's like, how do you know where to put him in for? He's got to go in everywhere. Just like if you knew G of 5 was 3, you put 3 in for both spots. So, yuck. What a mess here. So I'm going to write f of G of X equals, into parentheses, I am literally putting x squared. This guy went in there, right? And would you believe that that thing is getting squared also, right? So that's kind of weird. Plus 3 times x squared plus 1. And just check that out for a second. If we step back, if I change this back to red, which I was trying to do, would you see that this is almost the exact same thing as the original f, but where there was an x, we put x squared in its place instead. Now it's just cleanup time. What's x squared? Squared. What do you do with those exponents? Add them or multiply them? You multiply. I know in this case it doesn't matter because 2 plus 2 is 4 and 2 times 2 is 4, but in a general sense you multiply those together. So that's x to the 4th plus 3x squared plus 1. And we'll go put him up in here. And then we check out the domain. Everybody was invited in the first place, right? Nobody snuck downstairs when we this is the weirdest game of them all, you know, it's like we're doing the composite game. Nobody snuck downstairs underneath any even radicals, so the domain was still everybody. Let's see if we can set up g of f of x. Put f into g. Just set him up and we'll do the work together. Set him up. And since this has to go in for x into the g function, it's like you put that whole trinomial in parentheses and it's getting squared. So, yay! We get to square a trinomial. There is a shortcut. You have to be really good at Pascal's triangle to know the shortcut. And you're like, excuse me, what's Pascal's triangle? But there is a shortcut. Take calculus and you'll learn that shortcut. Let's not do the shortcut. Let's write him times itself. When you square somebody, take it times itself. So check it out. We're going to take 3 dudes times 3 dudes. Before we clean up any like terms, how many dudes should you get back? 3 dudes times 3 dudes is 9 dudes. So let's multiply that out. I like to stack these myself. Strike out the first guy. I did him. See if you can get the other 2. I'm going to pause. You can do that and then unpause. So I got all 9 of my dudes. The first one was in blue. Then I took 3x times everybody. You know, it's so easy to make a little boo-boo on your exponents or stuff like that. So just take your time. I got all of this. And then taking 1 times this guy basically repeats itself. Combine like terms. So x to the 4th. X cubes. There are 6 of them. X squared, 9, 10, 11 x squareds, and 6 x's, and 1 constant. Again, with my stacking procedure, 9 times out of 10, your like terms line up diagonally like this, you know, but it doesn't happen every time. It depends on what the degrees of these guys are. Everybody was invited in the first place, and nobody snuck downstairs or went underneath, so everybody's still cool for the domain. Messy, you know, it's just algebra-y, you know, but it's not that big of a deal. So let's see what the next guy is. Why don't you guys try just part A, right? So who goes into who, though? Everybody's invited here. Everybody's invited here because you don't see any radicals or anybody in the basement, right? Who goes into who? Does F go into G or does G go into F? G goes into F. So let's get that one done real quick. So I have taken the g function of 2x and put it in, and now these are all monomials, right? 1 term being cubed, 1 term being squared, so I don't need to do any foiling, excuse me, or any of that stuff. But I do need to take everybody here. Do you guys remember what 2 cubed is? We've been practicing for a long time. What's 2 cubed? 8 x cubed minus. We got to do what first? Could I take the 5 times the 2, or should I take the 2 and square it first? Got to do the exponent, so this is really 4x squared right here, and then times that 5 if you want to write it like this and then maybe scratch it out and call it minus 20x squared. Some of you can handle doing that mentally. I'm cool with that, you know, but it's nice to do that in a couple steps. And this is minus 14x. And then I'll go combine like terms. 8x cubed minus 20x squared minus 14x. Nobody snuck downstairs. Nobody snuck underneath a radical. Since everybody was cool to come over in the first place, everybody's still cool. Please reverse, reverse. Find g of f of x, which looks like it'll be hard. It's much easier. I'll pause the video. Get that done for me, please. So as you see, by just putting this in for x, it's just basically the distributive property. That's 2x cubed minus 10x squared minus 14x in that case. And again, everybody was invited. Nobody got kicked out. Those are some of the most plain Jane composites. Yes, they're weird. You know, it's like, what an interesting concept. Why would you want to do that, you know? It's just the idea of when you have a story involved with it that kind of makes sense. But those were the plain Jane ones because would you believe that everybody's party was pretty cool in the first place. They never had to kick anybody out to get started with. So let's do the last one of these where everybody's cool to come over to F's house, right? But how about G's house? Not everybody can come over. Right? So who are the only people allowed over? Tell me about X. They have to be greater than or equal to 0. Those are the only people invited. Right? No negatives can come over to G's house. So that will affect our domain. The question is different here because the other ones, what we did last time, was saying, who is the restrictions, right? You know, now they're not asking us the restrictions, they're asking us the domain. So let's do the composites first and just realize, but the first function's domain rules the roost. Who's coming first on this guy, F or G? G. So his domain is ruling. Right now, you can only pick no negatives. So let's do the composite. Let's put this meow, 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 in for X. So let's do F of G of X. And realize you only invited the non-negatives over in the first place. Does it change at all when we mix it up and play a little game? Like this totally went in for X. There's nothing happening to X. It's not being multiplied by a number or raised into a power, so it's just kind of like you replace it. So this is the final answer when it comes to what the composite looks like. But we got to see if anybody else caused problems, right? We already kicked out all the negatives. When we did the composite, did anybody else cause problems in this case? Like, is this +2 affecting things? Or it's all about this not being negative. Did we do anything underneath that radical? Did anybody sneak under there? So nothing changes. Let's see if you can list the domain. Put this in interval notation instead. Doesn't it go from 0 included to infinity in that case? Let's do the old switcheroony around, but now F's domain rules the roost because it's like the first function rules. So F said everybody could come over. But that might change when we play the little game, right? So we got to see what happens. So G of F of X equals, we're going to put F into G, so that's got to go, let me erase for the visual learners. This has to go in for X, right? You can put them in parentheses if you like. So that goes in there. Is that cool with you? Like, whatever F was has to go in for X. X was underneath the radical. Sneaky stuff just happened, right? We just snuck underneath a radical in that, so some people are going to get in trouble. Even though this guy's domain ruled, right? Everybody was invited. It looks like we've got some sneaky sneakertons here to say, okay, we got to figure out who our domain is. If you need a little help figuring out your domain, you could always just take what's under the radical, regardless of what it is, and say it can't be negative. And remember, the way to say can't be negative is this, greater than or equal to 0. That's how you say can't be negative. And then solve for X. So isn't our only move to like subtract 2 over from that side. So X has to be greater than or equal to -2. This is our domain. Let's see if we can put it in interval notation. -2. Does he count or not count? He can be 0 because he's not in a denominator or anything like that, and go to infinity. So what's under the radical must be positive. This is the mathematical way to say you must be positive. You must be greater than or equal to 0 in that case. So then you end up solving for it. So yeah, watch out for those. The first function's domain kind of rules, but if there's more craziness, you know, after you put the composite together, you just kind of deal with it there. All right. Oh, sorry, I thought we had a story next. This is something that the ACT is big on. is seeing if functions are inverses of each other by using composites. This is a test question also, and I'll tell you straight up, there's a lot of people who do it wrong because they don't follow instructions. It's not like they're doing the inverse process wrong, but what some people do is they do the 4-step process on this, and 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 then they could say yes or no. That is a way to do it. It's a long way to do it. To see if functions are inverses of each other, when they tell you to use composites, here's what we need. We got to do f of g of x, we got to get x back. If we do g of f of x, and we get x back, both times, they are inverses of each other. If you get anything else, no. So that's what this says. F of g of x is the same thing as g of f of x, and they both have to give you x back. That's it. If they both result in x, they are inverses of each other. So easiest way is to dive in and swim. Let's find f of g of x. Who goes into who? Does f go into g, or does g go into f? G goes into f. So take and put him into here. That would be x plus 9 minus 9. And let's clean that up. What does that clean up to be? So good, right? To see if they're inverses of each other, we must get x back. Both times, though. Just getting it once is not good enough. You must show the other guy, so I'm going to go right below it and do g of f of x. And if I get x back again, then, dude, these are inverses of each other. So now it's the old switcheroony. This f has to go in for g, so that is x minus 9 going in and a plus 9. And cleaning that up, doesn't that turn out to be x? Since we got x back both times, it's a yes or no question. They're asking us, are they inverses of each other? What do you think, yes or no? That is a yes, because we got x back both times. What I would like to do is preview the next one. We're going to do it again. We'll do the work. But before we do the work, I want you to tell your neighbor, what do you think, yes or no? Do you think these are inverses of each other? Did a little survey. About 3/4 of the class feel that yes, this is going to be inverses of each other. And some of them, the rest say no. So let's find out. We will do the work. Let's find f of g of x. I'll do it in blue to keep myself consistent. Let's find f of g of x. Who goes into who? G goes into f. So I like to do this. And it's got to go into parentheses, right? Because there's something in front of that x. So that's going to be 3 times 3x minus 5. And then there's a plus 5 after that. Is everyone cool with the substituting in part? Clean up. Distribute. That's 9x minus 15 plus 5, which the last I checked is 9x minus 10. What were we supposed to get back if they are inverses of each other? X. Did we get x back? Nope. There's no need to go further then. If you don't get x both times, then it's a no. And if it was the first time, hell, why do the extra work? You know, it's like it's already no, they're not inverses of each other. And for those who thought why, you see the plus 5 and the minus 5, those are inverses, but this is a times 3 and this is a times 3. It's like you would probably need to divide by 3 in one or the other one for them to be inverses of each other. Also, don't go by looking, go by math. Now the story that I was looking for. I am going to let you guys read it and see if, then we'll talk about it. So please read this. We notice there's a typo. You have a coupon good for $5 off the price any large pizza. So sorry for the typo. All right. So now you can read that correctly. All right. So the cost of using the coupon will be C of x equals the price of the pizza, which they say x, take away 5. If we use the coupon, it's just here's the price of the pizza, take away 5. And the discount, since they're taking 10% off of the pizza, we're going to pay 90%. So that's why it's 0.90. I don't really need the O, though, times x. So since we're saving 10%, we will pay 90%. To find these, it's about if they're doing the discount first, then using the coupon, or the coupon first, then using the discount. So discount first. So that means this is going in for here. So I'll do C of d of x equals, got to put 0.9x in here. So that's pretty basic. And then if we do the reverse, I want to use the coupon first, so this guy has to go in for x over here. That's going to be let's do d of c of x, and 0.9 times, if my pen would ever change colors when I ask it to, x minus 5. Well, we need to distribute this to see what's going on. That's 0.9x minus, when you multiply it out, you get negative 450 in that case. So these are definitely not the same deal. We're trying to buy a pizza here, and it's like here, if we use the discount first, we'll end up taking 90% of the pizza and then take away $5. But here, if we use the coupon first, it's like, oh no, my little coupon got discounted by 10%, so it's the 90% of the pizza, only take away $4.50. So A is the much better deal for us. Yeah, it's only 50 cents, but still, it's money in the long run. So cool. Let us know if you have any questions. Have a good one.